Alright, so we're going to look at 2-4, writing equations of lines. Or writing linear equations. There are two forms that we're going to use, two forms of a line, or two forms of the equation of a line. One will be y equals mx plus b, which, going over homework, we just talked about this, where this is your slope and this is your y-intercept. If the equation is solved for y, you have it in what's called slope-intercept form. So that's one of the forms that we're going to use, bless you. The only time I will use this form of an equation to start writing the equation of my line is if I have been given the slope and given the y-intercept. It's the only time I will start with this equation. 9 times out of 10, you're going to finish with this equation. You have to read your directions. They could ask you to write the equation in slope-intercept form. They could ask you to write the equation in standard form. Useless, but we went over that. So do look to see how you end your equation. But just because you end your equation in standard form doesn't mean you start it in standard form. Just because you end your equation in slope-intercept form doesn't mean you start it in slope-intercept form. Again, the only time I'll use this form is if I am physically given the slope and I have the ability to find the y-intercept. Either I'm given both of them or I have the ability to easily find it. Otherwise, I'm going to use the second form. Y minus y sub 1 equals m times x minus x sub 1. These points right here would just be an ordered pair that you've been given. So on 2-3, when you're told that your line passes through this point, that's your x sub 1, y sub 1. It's any ordered pair that's on the equation of that line. It could be the y-intercept, it could be the x-intercept, it could be any other point. There's an infinite number of values that they could give you for just one ordered pair. And then, of course, this is your slope. So this one is called point-slope form, and it is one of the most useful forms of writing an equation of a line. Point-slope form is the equation I'm going to start off with 9 times out of 10. We usually don't write our answer in point-slope form. You could be asked to write your answer in point-slope form, but usually you'll be asked to answer the question in this form. But I'll start with this form and end with that form. That's usually the best use of those equations. So let's go ahead and look at some formulas or problems. I'm not cut away yet, as I'm sure you're not either. All right, so here's example 1. So example 1, you are to write an equation in slope intercept, squeeze that in there, form for the line that has a slope of -3/5 and passes through -2. So even though our final form of our line is in slope-intercept form, that doesn't mean I'm starting with it. Look to see what they've given you. What have they given you? Slope. That's important. That's good. So this is m. What else have they given you? Is this the y-intercept? Is this point the y-intercept? You can tell if it's the y-intercept if there's a 0 in it. Where would the 0 be for the y-intercept? At x, right? It's always the opposite variable. So this is not the slope-intercept. This is actually x sub 1, y sub 1. It's just a point. So if I've been given a point and a slope, what am I going to start with? Point slope. So step 1, you're going to start with y minus y sub 1 equals m times x minus x sub 1. You will only plug into y sub 1, m, and x sub 1. You will plug in those values, and we found them up here. We have, here's x sub 1, here's y sub 1, and here's your m, your slope. So 100% of the time, you will see me writing the template y minus equals something, parentheses x minus, and I'll leave blanks in there. Why? Because of the negatives here. Just like in the slope formula, if I'm going to plug in a negative value, it ends up changing the subtraction signs. So be really careful. I'm plugging in for y sub 1, make sure you plug in the right value, negative 2. I'm plugging in for m, negative 3/5. And I'm plugging in for x sub 1, 5. If you were asked to leave this equation in point slope form, here's as far as you would have to go. You'd have to take care of any double negatives, and that would be it, or zeros. So if I had a 0 here, what's y minus 0? Y. Or if I had a 0 here, what's x minus 0? Just x. So you'd have negative 3/5 times x. That would be it. You might have y minus something over here or y plus something over here. You would leave it. It's uncomfortable. But if they wanted it in point slope form, you don't do much with it. You take care of double negatives and the value of 0, and that's it. You don't move anything right or left. You don't distribute anything. So point slope for this one would look like this. Y plus 2 equals negative 3/5 times x minus 5. That would be point slope form done. What do they ask for? Slope intercept. So we're going to go ahead and distribute. Sometimes I'll distribute this, sometimes I won't. It depends on how ugly it gets, because sometimes when I distribute the slope to the constant here, it gives you an ugly fraction. We can talk about how to deal with that as we go. But won't it cancel out on this one? So I'll have y plus 2 equals negative 3/5 times x is negative 3/5 x. And negative times a negative is a positive. Put 5 over 1. What happens to these 5s? They cancel. And I end up with just a 3. And then I want to be solving for y to get it into slope-intercept form. So subtract 2 from both sides. Don't I get y equals negative 3/5 x plus 1. Right? So 9 times out of 10 you're going to use point slope form, especially if you give a point and a slope. Alright, let's look at number 2. Can I flip it? So example 2. This is the one that requires the most amount of work. What is an equation, or what is the equation? Of the line through 2, negative 3, and negative 3, 7. They don't say what form, final form of the equation that we want it to be in, so they don't say what is your assumption. Slope-intercept form. If they don't tell you what form to finish your equation in, assume it's y equals mx plus b, slope-intercept. So they don't tell us that. Are one of these points my y-intercept? Nope. Do I have a slope? Nope, but I have 2 points. So we are going to use point slope form because I don't have a y-intercept. I definitely don't have a slope. the first thing that I do want to find is what? I have to find my slope first. So step 1, find your slope. So we've gone over the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And here's your template. If I were you, I would label these ordered pairs. It doesn't matter which is point 1 and which is point 2. So I'm just going to label them x sub 1, y sub 1, x sub 2, y sub 2. So for y sub 2, I'm going to put it in here, and I have 7. For y sub 1, it's negative 3. So I've got 2 negatives, minus and minus. We'll take care of that in a minute. For x sub 2, I'm putting in negative 3. And for x sub 1, I'm putting in 2. Then make sure you add the opposite before you do anything. So plus plus and plus minus. And then go ahead and add. So I get 10 over negative 5. Doesn't that give me negative 2 as a slope? So now I have my slope. I'm going to use my slope and a point, but I have 2 points. How do I know which point to choose? Doesn't matter. Typically, I'm going to look for a point that either has 0 in it or it has no negatives. Do I have that case here? Either one is as ugly as the other one, I guess. At least there's not 2 negatives. Let's put it that way. So if some of you want to choose this point and plug in and do what I'm doing, I'm going to choose this point just because it's a 50-50 on this particular one. It doesn't matter. But if you want to go ahead and choose this point and plug in, we will both get the same equation. So if somebody choose that one and plug in, I'm going to choose this one. So I'm going to use point slope form. So y minus y sub 1 equals m times x minus x sub 1. And again, I'm only plugging in for these 3 values. The plain x and plain y, you leave alone. So y minus blank equals blank times x minus 1. Plug in your values. My y sub 1 is negative 3. My x sub 1 is 2. And my slope we found over here is negative 2. So take care of your double negatives. Y plus 3 equals negative 2 times x minus 2. Distribute. Y plus 3 equals negative 2x plus 4. Subtract 3. Y equals negative 2x plus 1. Who plugged in the other point? This one. And got the same answer. Okay. So where's it? So it doesn't matter which point you plug in, so long as our answer is in. Now, if he plugged in the other point and I asked you to have the answer in point slope form, wouldn't we have different answers? We would. But if we both have it in slope intercept form, we're both going to have the same answer. So that one requires the most amount of work. Then let's look at example 3. Now the other thing I could do to you is give you a point and give you a line that's parallel or perpendicular to the line that you're writing the equation to, and that'll give you some information on slope. Thank you. So you are to write an equation for the line that passes through 3, negative 2, and is perpendicular to the line whose equation is y equals negative 5x plus 1. Oh, sorry, thanks. So we have to do a little detective work here. Do we have the y-intercept of our line? No. So I'm not going to use slope-intercept form. Do they tell me what form my final equation has to be in? No. So what do I assume it is? Slope-intercept form, but that's not the form I start with. I do have a point. So here's my point. This is going to be my x sub 1, y sub 1. So since I have a point, I need to find what? What do I need to find? Slope. And then I'll use point slope form. So the very first step is find your slope, because we have the point. This line is actually solved for y, isn't it? So the slope of this line, if your line here that they've given you is not solved for y, you need to solve it for y, so it's in slope-intercept form so you can see the slope. If it's not solved for y, you can't see the slope. So what's the slope of this line? Negative 5. But our slope is perpendicular. What's the perpendicular slope to this line? To negative 5. Positive 1/5. This is the slope that we're using, not that one. So we don't want that slope. So now we're going to use our point slope. So you go ahead and use your point slope, and I will quietly do it up here. Now at this point, you have a couple of choices. If I'm going to subtract the 2 to solve, I'm going to have to subtract the 2 and add a negative 2 and a negative 3/5. If you don't want to deal with the fractions, what could you do? It makes it a little bit longer work, but if you don't want to deal with the fractions, what would you do? Yeah, what's your least common denominator? 5. So I'd multiply this entire side by 5, which means every term, and this entire side by 5. I'm going to put it 5/1, which means every term. That way you don't have to deal with your fractions. You don't have to find the least common denominator of 2 over something. You can just deal with it. It'll all work out itself. So you would have 5y plus 10 equals, the 5's here cancel, so you're left with x. The 5's here cancel, so you're left with a minus 3. So then to solve for y, you're going to subtract 10. You get 5y is equal to x. Negative 3 and negative 10 is negative 13. Then you're going to divide everything by 5. So you get y equals, take x out of the fraction. You have a 1 left over in the numerator, so that 1/5 x comes right back to what we had up here. But you end up with negative 13/5 without a whole lot of headache. So if you don't like dealing with fractions, it's a little bit extra work, but it's easy math. You're done. What if I had given you a line that was parallel? What if I had said that your line was parallel to this one? Yeah, so let's just do a, for chuckle's sake here. If your line was parallel to y equals negative 5x plus 1. How does that change your solution? You're still going to use that same point of 3, negative 2. So now what's the slope that you're going to use? What's the slope of this line? Negative 5. Won't you use the same slope? Parallel lines have the same slope. You're still going to use the same point, 3, negative 2. So this becomes your x sub 1, y sub 1 again. And so use your point slope form. Wouldn't that become your answer? So whether it's parallel or perpendicular, you can figure out a way to find that slope. Make sure that you solve that equation that they give you for y. If it's not, use the ordered pair. If they give you two ordered pairs, find your slope, point. That's pretty much all that you're going to be working with today. Now, something that they might give you, one last thing would be perhaps this. What if I gave you, what example is this, 4? Is that right? So example 4. Write the equation of the line. With an x-intercept of 5 and a y-intercept of -3. Couple things here. Thing 1, have they given you the y-intercept? Yes. I'd actually use slope-intercept form for this one. However, do you have the slope? No. Haven't they given you two ordered pairs? What's the ordered pair for an x-intercept of 5? What's the ordered pair here? X-intercept, which is 0. The y. So the y would be 0, so because it's x-intercept, it makes sense that x would be 5. And then the ordered pair here for the y-intercept, what's 0 for y-intercept? The x, and it makes sense that y would be -3. So this is actually my x sub 1, y sub 1, x sub 2, y sub 2. Now I can find slope. So step 1, I would find slope. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Plug in your values. Y sub 2 is -3. Y sub 1 is 0. X sub 2 is 0. And x sub 1 is 5. Definitely add your opposite, even if you think you don't need to. But lots of sign errors on this particular problem. So -3 plus 0 is -3. 0 plus -5 is -5. What's my final slope? 3/5. So now that I have slope, isn't this equal to m? Now that I have slope and my y-intercept, isn't this equal to b? As my m and my b. Can't I skip all of that point slope form and use a shortcut and use y equals mx plus b? And then all I have to sub in for is m and b. That's what I'm going to do. Y equals, my slope we found was 3 over 5. X, what's the sign of b? Negative, so it becomes -3. Here's the equation given an x and a y-intercept. So if they give me an x and a y-intercept, boom, all I have to do is find the slope. But you have to find those ordered pairs to get that slope. I already have my y-intercept, so you're done. So sometimes there's value in using your slope-intercept form, but more often there's value in using that point-slope form. A lot of teachers don't teach with a point-slope form, but trust me, the math is a whole lot easier. All right, any questions? Okay.